Hello and welcome. We are discussing PYQs of number system and the theme is classification of numbers. We have done 3 problems already. Let's talk about this question. It says P and Q be positive integers. As soon as the word integers appear, there should be one thing in your mind. That point is no fractions, no decimal. Integers are complete numbers. Apart from that, the word positive is also present. So we'll talk about positive integers. What are positive integers? Examples are 1, 2, 3, 4, 5, and this goes on till infinity. Now, remember one more thing. Positive integers are also called natural numbers. What are positive integers? Whether you say positive integers, you say natural number, it is one as same thing. Next, over here a condition is given. Now it is such that the positive integer p is less than the positive integer q, and p plus q is equals to k. Now if you add two integers, your result will always be an integer. Suppose 2 is an integer, 3 is an integer. If you add 2 plus 3, your answer is what? 5. 5 is an integer also. Okay, so it is understood here that k has to be an integer here. And what kind of integer? Positive integer. Why? Because if you add two positive integers, your result will be a positive integer. Okay, now next, what is the smallest value of k that does not determine p and q uniquely? Okay, now rather than solving this question by assuming any random values of k, let's check out the option and let's try to solve this question with the help of option directly. We are looking for the smallest value of k. So pick the smallest option first. So option A is 3 and 3 is the smallest value present. So assume k to be equal to 3. K to be equal to 3. If k is 3, and we have to justify this condition where p is less than q, then think of two integers. Think of two positive integers whose sum is equals to 3. Okay. So sum of 1 and 2 is 3 and the sum of 2 and 1 is 3. In this possibility, p is 1, q is 2. We want p to be less than q. 1 is less than 2, so this possibility is considered. In the second possibility, p is 2 and q is 1. 2 is greater than 1, which means p is greater than q, so I cannot consider this possibility because this possibility will not justify this condition. So if k is 3, then we got a unique value for p, that is 1, and a unique value of q, that is 2. Hence 3 is not the right choice. Why? Because we are looking for that smallest k for which p and q should not be determined uniquely. Over here we got unique values, that is why discard this case. Now let's move on to next. Suppose k is 4. Suppose k is 4 and we want to justify this condition. Now, sum of two integers to be equal to 4 and p should be less than q. So it is possible when p is 1 and q is 3. P should be less than q. Sum of two integers is equals to 4 such that one integer out of them is smaller than the other. So we know 1 plus 3 is 4, 3 plus 1 is 4, 2 plus 2 is 4, but 3 plus 1 should be discarded. Why? Because we want p to be smaller than q. 2 plus 2 should be discarded. Why? We want p to be less than q. So for k to be equal to 4 also, we got a unique value of p, we got a unique value of q, hence this should be discarded because we are looking for those smallest value for which p and q should not be found out uniquely. Okay, I hope guys this is clear. Okay, now let's consider k to be 5 now. If k is 5 and we want p to be less than q, then see 1 plus 4 is 5, p is less than q. 2 plus 3 is 5, p is less than q. For k to be equal to 5, we got two different values for p, hence option C is the right choice. 5 is that smallest value of k for which we are not getting p, we are not getting unique value for p, hence it is the right choice. I hope guys this is clear. Let's move on to next question. Now it says, for what value of n the sum of digits in the number 10 power n plus 1 equal to is 2. So 10 raised to the power n plus 1 equal to 2. We want sum of digits. Remember, it is given sum of digits of this expression. So let's solve this question by option directly. First option says for n to be equal to 0. If I put n to be equal to 0, here it becomes 10 to the power 0 plus 1. Now, anything raised to the power 0 is 1. 10 to the power 0, so answer is 1. So 1 plus 1 is what? So option A is justifying my given condition. But let's check the other options also. Option B, it says for any whole number n. In whole, what are whole numbers? In which we do not include any fraction, we do not include any decimal, and all the numbers right from 0, 1, 2, 3, 4, 5, 6, this goes on. These are called whole numbers. So in option B, option A is already included because according to option B, value of n can be 0. So for n to be equal to 0, this condition is justified. Now let's consider n to be equal to 1. If n is 1, this expression will become 10 power 1 plus 1, which becomes 10 plus 1, which becomes 11. The digit sum 1 plus 1 is what? 2. Now option A should be discarded because it says the condition will get justified only for n to be equal to 0. But we just saw that for n to be equal to 1, the condition is justified again. Now let's say n is equals to 2. If you consider n to be equal to 2, it becomes 10 square plus 1. 10 square plus 1 is 100 plus 1, which is 101. Now sum of all the digits of 101 is what? So you can see that for any whole number, this condition will get justified. Hence, option B is the right choice. But let's talk about the remaining options also. Next, option C says for any positive integer n only. For any positive integer n only. This is not the right answer. Why? Because this condition is true for n to be equal to 0 also, and n equal to 0 is not a positive integer. Next, for any real number n. What are real numbers? The numbers that include fractions and decimal also. So let's say if we consider n to be equal to -1, let's check out, is this condition justified for n to be equal to -1? It becomes 10 power -1 plus 1. 10 power -1 is 1 by 10 plus 1. It comes out to be equal to 11 by 10, which is 1.1. Now 1.1 is not equal to 2. The digit sum of 1.1 is not equal to 2. 1.1 is what? Fraction. Digit sum is possible for positive numbers only. Digit sum is possible for positive numbers and 0 only. Okay. So option D is also nullified. Why? Because we took one value, one real number, that is -1, and this equation does not get justified. Hence, discard it. Let's move on to the next. Answer of this question was option B. Now again, I've told you that the concept of even and odd is very important. The concept of even and odd is very important. Now, in this question, 3 of the 5 positive integers P, Q, R, S, T are even and 2 of them are odd. Not necessarily in the order. Consider the following. First statement is P plus Q plus R minus S minus T. This condition is even. If you pay a close attention here, examiner says definitely even. Examiner says what? Definitely even. Okay, let's justify this. So I'm writing P plus Q plus R separately like this, and S plus T separately like this. This is one group. This is another group. Now, if the word definitely is present, then try to find out one such condition that is just opposite of the given. Definitely even. So try to find out one such assumption for P, Q, R, S, T, so that rather than getting even number in the result, we are getting an odd number. Okay. So to get an odd number in the result, why we are doing this? We are just trying to find out one such condition that will answer odd here. Why odd? Because the word definitely is written. When the word definitely is written, then try to find out one such condition which is just opposite of the given condition. Given condition is even, so just opposite of even is what? Odd. So try to find out one condition, one assumption for P, Q, R, S, T such that the answer is odd. If you want your answer to be odd, then odd answer is only possible when you subtract an odd number from an even number, or you subtract an odd number from, sorry, an even number from an odd number. Okay, this is only possible when you subtract an odd number from an even number and even number from an odd number. Yeah? Okay, let's talk about this condition. You want this group to be even. This group will be even only when P is even, Q is even, and R is even. This group will be even only in one condition, and that condition is when all of these three are even. It is given to me that out of these five, three are even and two are. So if P, Q, R are even, then S has to be odd and T has to be odd. If you do odd plus odd, can I be getting odd here? No. Odd plus odd is even. So to prove it to be odd, we picked a condition and it is not possible to justify that condition. Okay. So discard this possibility. Discard this possibility. Let's talk about second possibility. You want answer to be odd. So it is possible when you subtract an even number from an odd number. You want this to be odd. This is possible when one number out of these three is odd. It is possible when one number out of these three is odd. See, suppose if P is odd, Q is even, and R is even, the answer gonna be what? Odd number. See, even plus even is what? Even plus odd is what? Odd. Okay. Now, if you get two odd numbers here, and one even number. If you got two odd numbers here and one even number, so odd plus odd is even does not justify. Okay, if all these three are even, all these three are odd, so P, Q, R, these three cannot be odd simultaneously. Why? Because only two odd numbers are present. Hence, if you want P plus Q plus R to be odd, it is only possible when one out of these three is odd. Let's say P is odd. If P is odd, then Q has to be even and R has to be even. I got five numbers. Out of five, three are even, two are odd. Two even numbers are gone. So out of S and T, one has to be even and another has to be odd. Okay, now odd plus even is odd, but even plus odd is what? Even plus odd is odd. So whatever possibility we are talking about, it is not possible to make this thing to be even. Hence, it is not possible to get odd as the result. It means all the possibilities of getting odd are discarded. Hence, the statement 1 is absolutely correct. Okay. Now, let's talk about second case. In the second case, 2P plus Q plus 2R minus 2S plus T is given, and definitely odd is what examiner is saying. Definitely odd. So I will try to find out one condition which is opposite of odd. Why opposite? Because definitely is written. So I will try to make the result. I will try to find out one such case for which this whole thing will be even. So let me write down 2P plus 2R minus 2S plus Q plus T. 2 is P plus R minus S plus Q plus T. Suppose, see, 2 is what kind of number? Even number. even number multiplied with anything, even number multiplied with anything will produce even number in the result. 2 multiplied with any value will produce even number in the result. Plus, suppose by chance if Q is odd and T is odd also. So odd plus odd. Why I am considering Q to be odd and T to be odd? Because I know there are two odd numbers and those two odd numbers can be Q and T. So in that case, odd plus odd is what? Even. For this possibility, the answer of this expression is what? Even, which is what? Just the opposite of the given condition. Hence it is not true, because the opposite is possible. Opposite of odd is possible for this expression. That is why this is not true. So answer of this question is option A. I hope class you have understood it. Thanks and please take